Good morning. Just a morning quick one. I have a program I'm running for, so before we do that, okay, so I have a quick one. Like I said under here, I just feel like we can have something just for the morning. We have to look at organic chemistry. In this segment, I just want to have some few things that we're going to look at right now. And particularly, we'll be looking at alcohols. Maybe let me wrap from here and then have it typed. Okay, for the sake of space. Oh, sorry about that. Okay, so we can have this and then let's have it here. Okay, so we're saying we'll be looking at organic chemistry, and in particular, we'll be looking at the alcohols. And if you want to use the word alcohol, you can also call them alkanols. Alkanols. Okay, maybe let me even put a hyphen there. So these are what we call alcohols, and these are what we call alkanols. Now, among the alkanols and stuff like that, what is it that we're going to focus on? We'll focus on one. We can talk about the general properties of alkanols that might even come later. We have to look at the naming UPAC, the naming of compounds. Naming of compounds, can look at the general formula, of course, there are many. We'll also have to look at the functional group. What is it that give these compounds similar chemical characteristics? Functional group. We'll also have to look at the reactions they undergo. This is not the order. The reactions that go undergo, and then the methods of preparation. Yeah, these are things that we're going to look at. Unless I've forgotten some things, yeah, these are the ones that we're going to look at. Then under the method, under the reactions they undergo, we have to look at product, major, if they are even minor products, major and minor products. Okay, we also have to look at conditions, very important. Conditions, yeah, that are needed for the reactions. Very, very important. Yeah. Then methods of preparation. Yeah, it's also important you also look at other products. Okay, and the conditions needed. Very important. Okay, conditions. Yeah, very, very important. I think that we're going to look at. Maybe in the interest of time, we may not even finish them all. We'll just have some few things that we're going to look at right now. Then later, I might have a publication of another video where we might have a continuation or even something different. Okay, so what do we have? Yeah, we can get started right now. So we are saying we're looking at organic chemistry, and what is it that we can start with? Okay, so we are saying some few properties that we can look at. One, these are organic compounds. These, okay, let me say, yeah, they are organic in nature. the organic in nature. In nature, of course, some are polar, some are non-polar. It depends on the types of atoms that are present, as well as the arrangement, the stereometry, the geostereo, the arrangement in there. So some are polar. Some are polar, okay, and others are non-polar. Okay, this the chemistry that we didn't get of science may not permit us to talk about the polarity of the compound, the diap moment, the bond order, the position of the lone pair, yeah, stuff like that. We may not even go into detail. It's just important that you understand, or maybe just have it written there. Polar, some are polar, others are non-polar. Okay. The other one is that when you have these organic compounds left uncovered, someday we are expected to get a smell of it. Ethanol, let's talk about ethanol. We haven't looked at the classes of them and examples. When you leave ethanol in an open area, then you just walk in and walk out and walk in, you find that you can smell. I think there's ethanol somewhere there. Why? Because they are volatile. So the volatility is one of the properties that these guys exhibit. And then when you're in the lab, you're trying to bend something, maybe by the use of okay, by the means of want to have a Benson pen, you just want to pen a paper at the backside of the yard. We use ethanol. Even the sanitizer, with the one they say 9% containing ethanol, the sanitizer is able to burn. So we can say that it is used as fuel in some ways. Okay, and then most of these organic compounds, most of these alcohols, most of them, can say most, if not all, most of them are what? Most of them are liquid at room temperature. Liquid at room temperature and pressure. Of course, the viscosity may change as the number of carbon atoms increase. Pressure, yeah. The viscosity increases as the number of carbon atoms does increase. So that's one thing we need to understand. Most of them are colorless. Because I've seen propanol, I've seen ethanol. Most of them are colorless. If not all, again, most of them are colorless. But I'm going to combine both physical as well as chemical properties. Then the other one is that these ones on the chemical side, they react with the organic acids. They react with the organic acids to produce esters. Produce esters and water. Yeah, because when you start looking at the esterification, we'll find that these are the guys that are important. Now, among the chemical reactions, it's a reminder of the reaction that we're going to talk about. And the name of this reaction is called esterification. Then the other one is that these guys are able to react with okay, they are able to react with oxygen, though the oxygen comes from potassium permanganate, potassium dichromate. So they're able to react with oxygen to produce carboxylic acids. And the name of this reaction is called oxidation. Okay. Then these same organic these alcohols, they are also able to undergo, though this may not be a property per se, they are able to, let me say, they're able to lose. Okay, they are able to, oh no, what have I done? What have I just done? It's supposed to be, I need to, oh, okay, can do this, okay. They are able to undergo the reaction we call dehydration. Dehydration is a process of removing water. So when we remove the water from an alcohol, we form an alkene and water. Because remember, the water is what we are removing. So when we remove the water from an alcohol molecule, we are likely to produce an alkene as well as water. These are just some of the reactions that they undergo. Then, from here, we can look at it. Remember, I'm a little bit quick, 7 hours, 8 hours, I'm expected somewhere. So I don't know if time is even on to allow me to, let me see how far I can go. Then we can look at the naming. How do we name these compounds? By the way, yeah, so how do we name the compounds? Remember, the naming of the compounds. So naming of compounds, naming of alcohols. The naming, there's a trend that we follow, and the trend is that you just need to add two things. So we add two things. One is a prefix. We add the prefix and the suffix. Suffix. Now the question is, what is a prefix? A prefix is extracted from the number. A prefix is extracted from the number of carbon atoms present. And they remember there's the order that we follow. When the carbon is 1, you say mono, 2. No, not that way, sorry. When the carbon atom is 1, call meth, 2, eth, 3, prop, 4, but, 5, pent, 6, hex, 7, hept, 8, oct, 9, non, non, then 10, dec, DEC, a dec. I'm a guira viamba dec. Yeah, so that's the prefix order that we follow. And then what about the suffix? If you look at the way the alcohol is spelled, I think that's the first thing I should have started with. Okay, I can still include it in here. So the suffix, how do we get to find the suffix? We're saying that the suffix is driven from the name alcohol. Yeah, I said alcohols are also written as alkanols, not ANAL. NAL in science, we don't insult. If you spelled like that, we're not insulting here. We're just having a change of the homologous series from an alcohol into what we call aldehydes. So we don't insult. When you say NAL, we're talking about an insult here. We're just talking about a shift of the nature of the compounds from alcohols into aldehydes. So it has to be AN or L, talking about the alcohol. So this part here is the suffix that we add to the prefix. The prefix is driven from the number of carbon atoms. So maybe let me labor a little bit on that. So the alkanols, the ALK tells us that there's carbon and hydrogen atoms. Those two are there because of ALK. There's carbon and hydrogen only for ALK part. There's no nitrogen, there's no oxygen, there's no hydrogen, there's no sulfur, there's no any any other, okay. But the functional group will also tell us the additional atoms, because this is a hydrocarbon derivative. An alcohol is a hydrocarbon derivative, meaning it is derived from a compound that has only carbon and hydrogen. It is a derivative because there is an addition of another type of an atom. So saying ALK tells us that there's carbon and hydrogen atoms only for now. But not only, because the functional group will prescribe the nature of other atoms that must be added. Then the ANOL, this is what we call the suffix. So that's the order that we use when we are told to name these alcohols. Maybe you can have a quick one. I'm just going to give one. The rest of them you can practice them on your own. So we're going to say example. Example will be, okay, the example will be suggest and the name of an app with, okay, can I have to A, okay, it's A, 3 carbon atoms, then 2, B, you can have, let me say 2 carbon atoms. Now remember what I said. What I said was, when naming them, all you need to do is just get the prefix, which is driven by the number of carbon atoms, as well as the suffix. So maybe let me prescribe the prefixes here. 1 meth, 2 carbon atoms, if 3 is prop, 4 is but, not but but. 5 is pent. 6 is hex, not hexe. 7 is hept. 8 is oct. 8 is oct. 9 is non. Then 10 mostly doesn't even go to 10, is dec. But when you advance in the studies, it goes all the way up to 12, but of course there's a combination that will follow. So this is the order that will be following when you're naming them. And of course, not forgetting the suffixes. Yeah, so the question here is telling us that way. So we're going to look at 3 carbon atoms. So 3 carbon atoms, what is the prefix? So 3 carbon atoms, the prefix is prop. So without wasting much of the time, we're going to have our stuff here, and then we see how far we can go. So the prefix is prop. So we're going to say prefix. It's very simple, friends. Prefix plus suffix, and then we get to have the name. Now, what is our prefix? We are saying for as long as there are 3 carbon atoms, the prefix is the prop. So prop plus the suffix ano, and the name becomes propanol. Beautiful. So that's how we're going to name them. Prop plus ano gives us the name propanol, because there are 3 carbon atoms that are present in there. As simple as that. Okay, and then we can go to the other one, which is this one here. But now in the interest of time, or because of space, I'll be forced to push it right over here. So we're saying that the number of carbon atoms this time around, there are 2. So unfortunately, space, okay, don't have to cross each other. So that is the one. And let's see how far we can go in establishing that. So without wasting much of the time, one thing that we know is that we're going to have the prefix, and then we add the suffix. Once we do that, we're going to have the prefix is eth, because there are two, then plus ano, the suffix, which is going to give us the name ethanol. Oh, wow. So that means the ethanol that we use in the lab, it just contains 2 carbon atoms. And if you want to sound more scientific and confuse the lab technician at your school, at the university, just go and tell him, sir or madam, I need an alcohol with 2 carbon atoms. Definitely that scientist is going to know that we're talking about ethanol. But do not change the homologous series that I need an acid. This is not an acid, this is an alcohol. Tell him or her that, sir, madam, I need an alcohol that has only 2 carbon atoms. Definitely that person is in a better position to know what you try and talk about. So that's what it means. So naming is very easy. You can go on and name as many compounds as you want, based on the number of carbon atoms that are present therein. Okay, the other one that we can look at is the functional group. Yeah, let's look at the functional group. Because minus knowing the functional group, it becomes difficult for us to draw the structure. Because the structure driven or are determined by the functional group. So you cannot draw a structure minus understanding the functional group. Functional group. Now, by the way, I did not define a functional group because I took the assumptions that you'd watched my previous videos where I talked more about this. So a functional group, I'll just say something about it. Maybe an atom. A functional group may be an atom or groups of atoms. Now, it being an atom or groups of atoms, these are attached to a compound. And because it is attached to a compound, it is the one that gives chemical characteristics of that compound. Those characteristics that we put up there to say they are able to react with an acid, organic acids, to produce an ester, esterification. It is because of the functional group that is present in the molecule. So for alcohols, the functional group is an hydroxyl group. Hydroxyl group is coming from hydroxide. It's a hydroxide, but mostly in organic, if there is a bond that is removed, if there's a bond that is removed from a compound, we put YL. Propene, we can say propyl, because this is the order that will be following. Even when naming the esters, yes, the esters, there's the point we put YL. If it's a propan which is reacting, and then we remove the one of the bonds, it becomes propyl. Ethanol becomes ethyl. So because of the presence of the free bond in hydroxide, it is called hydroxyl group. We of course know it's that. We know very well that it's that. So that is a hydroxyl. But remember, there is a free bond here on the hydroxyl part. So that is a functional group. So all the alcohols should have that. If you draw something which contains hydrogen and carbon, that thing is not present. It's no longer gonna be an alcohol. An alcohol is supposed to have that. Okay, very good. So that means all the compounds that are going to draw that fall under the alcohols, that thing must be present in them all. Okay, that's it. Then we can go to the other. So this could be part 3, because starting with the naming 1, or this is 2, and then we can go to 3. We can talk about the general formula. Now, when we say the general formula, what are we talking about? Remember, in mathematics, science, and other subjects, when you are using a formula, that formula is a formula that we use to solve many aspects. If they say you're finding what is the formula for finding the area of a triangle, we know that area is half L times H. That formula cannot change because it's general. So even here, when it's a general formula, you are trying to understand how many carbon atoms, how many hydrogen atoms may be present in a named alcohol. We go for the general formula. Now, the general formula is because the subscripts that are involved allow me to write them freehand. The general formula. So the general formula here is CnH2n plus 1. Then, of course, OH. There's something that I want you to understand. From here, there's CnH. Cn, let me draw here. Oh, where are you? Here. And there is this part. This part is just talking about carbon and hydrogen. Remember, that's what I said. The ALK part is on carbon and hydrogen atoms that are of great importance. Then the OH is just added because it is a derivative. And I'll show you where the OH comes from when you start looking at the formation of these alcohols. So that's a general formula. And when they ask you to now tell the number of carbon atoms, the number of hydrogen atoms, and all that, you should go to the general formula. Now, there's a formula which shows the number and the types of individual atoms that are present in a compound. That's what we call molecular formula. So you cannot do anything with a molecular formula if you don't know the general formula. So when they ask you to write the molecular formula, when they ask you to write the molecular formula of alcohols, when they say that alcohol has got 7 carbon atoms, go back to the general formula, because N in the general formula, N is talking about the number of only carbon atoms, because they're the ones that are of great importance here. Carbon atoms. Yes. That's what it means. That is what it means. So let's see if we can have an example here where we may be required to construct let me put up this space here. We're going to examples from where I may be required to construct the molecular formula. So let's say examples, okay. So we're going to put right here, we say one here. It says suggest the name and molecular formula for organic, just for alcohols with, okay. So that's what we can just have. Okay, with, maybe this can even go this side a little bit. I'm interested in the, okay, that going there. So with A, 2 carbon atoms. Then B, we can have, well, this was supposed to be A. Then B here, B with 1 carbon atom. Very simple. Remember, friends, the rule is that we first have to borrow some ideas from the molecular formula, the general formula, rather. So I'm going to borrow this here, we also borrow it there. Now, how do we go about it? General formula, CnH2n plus 1. So we're going to say C. No, this thing, the subscript may not be nicely written, just know that the numbers are subscripts. So C, the N here in the example A, the number of carbon atoms is 2. Then H, there is here where we are multiplying 2N. So we're going to say 2 times 2, because there are 2 carbon atoms. Then thereafter, we're going to add the 1 carbon atom. At the very end, we put OH. And once we come here, or first of all, I'm doing the molecular. The naming is very easy because there are 2, you know, that is ether now. So we're going to have C2. Let me just write it here the best way. So here, once we do the computation, we're going to have C2H, 2 times 2, 4, plus 1, 5, OH. So this is the molecular formula for the name we should know. It's ether now because there are 2 carbon atoms. Then when we come here, we are going to do the same. Now, when the prefix is, when the number is 1, you don't write it. So just say C. Okay, let me say C1, H, 2 times 1, N is 1 now, 1 carbon atom, then plus 1 at the very end, or H. And once we compute that, remember when the N is 1, you don't write it. So we're going to have C, H, 2 times 1, 2, plus 1, 3, H3, OH. So the trend goes on and on and on and on and on and on and on. The trend keeps going that way. That is all about the organic molecular formity. Then the last one that we can talk about right now before I go, because I'm rushing to town, something that I'll be doing there, we can just talk about the structure formula. How do you now show the arrangement of bonds, the carbon, the hydrogen atoms in the compound? Of course, here, because we understand very well that kids or students have not yet done the structure elucidation. So we may not be interested in the stereochemistry. We may not be interested in the stereochemistry. When I say stereochemistry, I'm talking about the actual positioning of the bond or that. Unless you do a little bit of structure elucidation, that's when you might understand every bit of it. So the last one here, the interest of time, the 6th point is that we have to look at now the structure formula, talking about the arrangement. How are these bonds spread? In case you get interested, you want to go into the inside of the ether now. I remember that's what that Indian guy was telling us, that if you want to understand better the reactions, you go inside of the water. If you're reacting water and salt, jump inside of the beaker and see what is happening to the bonds in there. So the last part of it, sorry, I'm a little bit fast, but I hope you understand. Okay, so we're going to look at, we'll just go direct into examples. Suggest, okay, draw. Question 1. Draw the structure of the following alcohols. Yeah, because I'll take the assumption that you have understood everything that we have done. So I'll just give you, supposed to be AA. I'll just give you the chemical, the molecular formula, then you can connect the structures. So number, just give you 2, the rest you can do. A, we can have C2H, remember, 2 times 2, 4, plus 1, 5, then OH. The other one is the one that we just did. C1H3OH. The first one is ethanol. The second one is methanol because of, so this is ethanol. Then this one is meth from one carbon atom. Very easy. Methanol. Okay, methanol. Very good. We can even maybe enclose them in here so that we understand that they are driven from the same material. Okay, so how do you go about it? Remember what we said? What we said is that okay from alkanol indicates that they are carbon bonds that that must be arranged. All the carbon atoms, by the way, must be connected with a single bond. So how many carbon atoms we have here? We have 2. So we're going to have 2 of them in a linear if you want, because I haven't yet looked at isomers. So carbon, there are 2. Okay. Then how many hydrogen atoms? There are 4. Understanding very well that carbon should have 4 bonds. So carbon 1 here already has 1 bond. So we have, let me use blue, no, black, red. Okay, black. So we already have 1 bond here. So we're going to just add 3 more. These ones are for hydrogen. From 5 hydrogen, we can even put hydrogen here, and hydrogen here. Out of 5, we have used 3. We are remaining with 2. So 1 here, 1 here. They are already 5, you can confirm. But carbon should have 4 bonds. Yet the last carbon here is only 3. So there must be the third one. That is the one where the OH is attached. So if you want, you can put a hyphen there showing the bond. If you want, just put OH. It's okay. So this is a structural formula for what? For ethanol. 2 carbon atoms in a line, single bond, 1, 2. Then there are 5 hydrogen, 1, 2, 3, 4, 5. But the last one is having 3 bonds. So the third bond gets to OH. That is ethanol. Then for B, methanol, it already has 1, just 1 already. So there's nothing like single bond. Single bond with what? Single bond in a child. So we just put this 1 here. 3 hydrogen atoms. We are saying carbon should have 4 bonds. 4 bonds. These are the 4 bonds. But yet we have 3 hydrogen. So we're going to supply here. We supply here. And we also supply here. We have 1 bond remaining for the addition of OH. So this is the structure formula for methanol. That is a structure formula for methanol. I'm interested in the thing here. Yeah, I'm going to put them in the box. So this is a structure formula for what? For, and I can also put yellow. Yeah, it's a structure formula for methanol. The program is very simple. And if you follow it here, of course, you're not going to find some difficulties now. Let me do the last one before I try to go take a shower. I hope you understand. The last one is this one here. The last one is this one here. Oh, okay, let me just clear them all. It's okay. I'm talking about the structures. So the other one is suggesting the structure for a compound that has 3 carbon atoms. 3 carbon atoms. 3 of them. How do we go about it? So I've changed now. Yeah, this is a different question. 3 carbon atoms. So how do we go about it? We're going to use a general formula. CnH2n plus 1, then we add OH. So 3 carbon atoms, we're going to have C3H2 times 3 plus 1, then OH. The molecular formula will be C3H2 times 3, 6 plus 1, 7 OH. 3 carbon atoms, we're going to draw them in a line, in a single line, a single bond. It's that not always, but just looking at the basics. So we have 1, 2, 3. and put these bonds. God knows what is coming there. We're just drawing the bonds. Confirm each carbon atom has got 4 bonds. And then this, how many hydrogens? 7. So we're going to have 1 here, going to have 2 here, going to have 3 here, going to have 4 here, going to have 5, 6, 7. And whenever you supply the bonds in the carbon atoms, we are just remaining with 1 bond for the addition of OH. 7. So this is the propanol. Propanol. This is the name, the molecular formula, and the structure formula for an alcohol that has 3 carbon atoms. Okay, I'm afraid I gotta go now. I wish I could continue and continue and continue, but time is not allowing me. If you have more inquiries, you can just reach me out on, by the way, you can search for my YouTube, Kundamlenga, and then my phone number is +2 6097 5578 694. Okay, you can find me on WhatsApp, and then that's my YouTube name for more videos and more interesting stuff. So for now, goodbye.